Tesla held their much anticipated Battery Day recently, where they revealed their vision for the future of the company. Based on the dive the stock's been taking since the announcements, it's easy to assume that their offerings were a bit underwhelming, to say the least. But I think this reaction is due to a lack of understanding of just how significant these innovations are. That's why in this video, I'm going to share with you the many reasons why Tesla just won the decade. Hey everyone, Brandon here, and this is Time to Adult. If this is your first time here, thanks for stopping by. If not, thanks for coming back. In the next year or two, we could see a quantum leap in our transition toward a sustainable future, and Tesla seems positioned to be at the head of it all. That's why in this video, I'm going to share with you 9 reasons why Tesla has won the decade. So let's start with terawatt-hour scale production. The battery is the core technology of an EV, and Tesla's biggest supply constraint to growth is battery production. During Battery Day, Tesla laid out their plan for scaling battery production, and it starts with the terafactory. Producing batteries at the scale they need will require fewer factories with higher output. Through innovations in manufacturing, Tesla's new terafactories, possibly starting in Austin, will have a 10x reduction in floor space per gigawatt hour and a 75% reduction in investment per gigawatt hour. This means terafactories will have a smaller footprint than a gigafactory, while producing on a scale an order of magnitude greater. Next, let's talk cell design. Tesla introduced their new tabless 4680 cells, which boast 5x energy, 6 times the power, and a 16% increase in range with almost no change to charge times. The new design will greatly simplify the manufacturing process, which will further reduce cost and increase production rates. They also shared their dry electrode process, which will further reduce factory floor space required by removing massive ovens needed to dry the battery electrode slurry. Let's move on to cathode and anode improvements. One of the biggest issues with EV batteries that aren't lithium iron phosphate is the cobalt content. In my Tesla mining video, I mentioned that cobalt is a highly problematic element, as it comes from the Democratic Republic of Congo, where the mining process is reported to use child labor. It's also pretty expensive. Tesla's new high nickel cathode will solve these problems, which will reduce costs by 15%. They also plan to use raw silicon in their anode to increase range by 20%. Tesla also plans to simplify the cathode process by using raw nickel, which will reduce cost and environmental impact. This is because the use of raw nickel significantly simplifies its processing. It also improves sustainability by making it easier to use recycled nickel, further reducing Tesla's impact to the environment and cost. Now let's take a look at trifurcation of batteries. To address the battery shortage due to raw material and production constraints, Tesla is essentially going to use every battery that they can get their hands on. They plan to use the more affordable and longer life lithium iron phosphate batteries for power pack grid storage, Model 3 production, probably in China only, and their more affordable $25,000 vehicle, which they also mentioned during the presentation. Though it doesn't look like we'll see it for another 2 years or so, this chemistry will also be useful in their robotaxi fleet for its high cycle life. NMC chemistry, or NM now I guess, will contain 2/3 nickel and 1/3 manganese, and will be used in Tesla's core sexy vehicle lineup, which includes the Model S, Model 3, Model X, and Model Y. It'll also be in the Powerwall. This chemistry offers superior range and power to LFP, and is good in general consumer use vehicles. They're also coming out with a high nickel chemistry, which will offer the highest energy density and be used on mass-sensitive vehicles like the Semi and Cybertruck. Splitting battery use by application will allow Tesla to improve efficiency and production through diversity of supply chain. Tesla won't have to worry about cell production of the Cybertruck being interrupted by Model Y supply needs, and vice versa. Next, let's talk Tesla mining. So it turns out I was right about Tesla getting into mining, but I was a little off as far as location and the element that they'll be mining. Tesla plans to mine lithium through a new extraction process that will use salt to pull lithium from the clay. This new mining operation will be located near their gigafactory in Nevada and will reduce cost as well as the environmental impact from transporting the raw materials. I mentioned Tesla taking control of their own destiny in a previous video, and it appears that they are indeed serious about this. By developing mining operations, Tesla will have significantly more control over the most critical element of their supply chain. I'm excited to see how this mining implementation goes and what other elements they will mine in the future. Tesla also plans to build a localized cathode plant to lower costs and transportation impacts. This map has me curious though. Did they put the cathode plant in Oklahoma because it's the center of the United States? Or perhaps they put it here because they're still eyeing Tulsa as a potential location. Now let's move on to giga casting. Tesla's implementation of giga casting, which will cast the Model Y rear body as a single piece, will significantly reduce the cost and complexity of the vehicle, taking 80 parts to 1 part. To achieve this, Tesla has commissioned the largest casting machine in the world. They've also developed their own alloy to withstand the casting process and harden without heat treating. This speaks to Tesla's advancements in material science, which at this point, other automakers can't hope to match. Now let's check out the structural battery. Probably one of the most interesting announcements to me was Tesla's plan to integrate batteries into their vehicle structure. Using the evolution of aircraft fuel tanks as an example, Tesla plans to remove all the excess structural elements of the battery pack and incorporate batteries into the structure of the vehicle. This will significantly reduce mass and allow tighter packing of batteries, enabling higher energy density at the pack level. The result of this will be both mass and range improvement, as well as improved structural integrity. This will of course have a positive impact on the factory and production due to fewer parts and further simplified manufacturing. Is it just me, or does the factory look like a computer chip? According to Elon Musk, the best part is no part. The best process, no process. With these reductions in parts and further simplification, Tesla is able to further lower costs and gain efficiency. Next, vertical integration is Tesla's moat. Tesla's vertical integration is what makes their vehicles superior to other EVs. And Battery Day laid out the roadmap to further vertically integrate, from cell design to materials to factory improvements to integration into vehicles. Tesla has reduced costs and manufacturing complexity by taking production further in-house. The techniques discussed will result in a 54% range increase, a 56% cost per kilowatt hour reduction, and a 69% reduction in investment per gigawatt hour. Traditional automakers can't hope to match Tesla's efficiency in manufacturing, and I think Tesla's lead is actually accelerating. Finally, let's look at the $25,000 model. Tesla didn't say much about their new $25,000 model other than the fact that they're making it. EVs have always been a bit expensive, and to the average consumer, they aren't worth the upfront cost. But Tesla has continually decreased the price of their vehicles by improving the manufacturing process and battery technology. The company acknowledges that in order to achieve their goal, they're going to have to lower their prices further. And the $25,000 model is another way they can make their vehicles more accessible. Tesla plans to use LFP batteries for their new model, which is already a low-cost option. By the time this vehicle reaches production, Tesla will be able to apply all that they've learned in the vehicle manufacturing space to reach price parity with the Honda Civic or Toyota Camry. This will be critical to accelerating the transition to sustainable energy, as upfront cost is the primary discriminating factor for most drivers. Overall, Tesla's Battery Day seems to have underwhelmed the broader market, which I attribute to a lack of understanding of the technology explained, as well as a shorter term view on the company. This, however, creates a buying opportunity for long-term investors who understand Tesla's narrative. I'm not surprised by the market's reaction, as Tesla did lay out a plan that covers the next couple of years versus one that covers the next quarter. Most people were probably expecting a flying car or something, but for those who understand what's really at play here, this is incredibly exciting and points to a highly profitable and prosperous future for the company. This isn't investment advice or a prediction of the future. It's just my opinion as a Tesla owner, shareholder, and fan. But what do you think? Was Tesla's Battery Day a win or a flop? What announcements were you most excited about? Have you bought or sold Tesla stock since the presentation? Let me know in the comments. If you like this video, be sure to like, share, and subscribe. This is a new channel, so I'd really appreciate it. With that, I'm Brandon, and this has been Time to Adult. Thank you so much for watching, and I wish you the best on your journey toward a better tomorrow.